Have you ever stopped and wondered how a massive automated factory actually works? I mean, how do all those different robots, sensors, and controllers from dozens of different companies all coordinate perfectly? Well, let's get into it, because the secret is a common language. And today, we're breaking down the universal language for machines, OPC Ua.
But first, let's imagine the opposite. What happens if your machines can't talk to each other? Just picture it. A factory floor where a robot arm from one company speaks German, a conveyor belt from another speaks Japanese, and the main computer only gets English. It would be pure chaos, total inefficiency. And you know what? For a very, very long time, that was pretty much the reality of industrial automation.
And that chaos brings us perfectly to our first section here, the Industrial Tower of Babel. This really gets to the heart of the problem that plagued manufacturing for decades, a world filled with proprietary, walled-off communication systems.
This slide just lays it all out. The old way, it was a total nightmare. If you had, say, an Allen Bradley PLC and you wanted it to talk to your control screen, your HMI, you needed a specific proprietary driver just for that one connection. Then you want to add a Siemens PLC? Well, guess what? You need another, completely different driver for that. It created vendor lock-in and systems that were just unbelievably complex and, frankly, not very secure. The goal was simple, but it felt almost impossible. One single, secure standard for everyone.
So how did we even start to fix this? Well, the first real attempt at a solution was something called OPC Classic. It was a fantastic effort, a huge step in the right direction, but, and this is a big but, it had a critical flaw.
So back in the mid-90s, the original OPC standard, we now call it OPC Classic, showed up. And at the time, it was a game changer. It took all those different PLC protocols and kind of wrapped them in a common interface. It was adopted everywhere. But as technology raced forward, its limitations became painfully obvious. Security was a huge issue, and it was completely chained to one company's platform. By 2008, it was clear the industry needed something new.
And right here, this is the heart of the problem. OPC Classic was built entirely on old Microsoft technologies called COM and DCOM. Think of it as the glue that held software together, on Windows. And this meant two massive things. First, it only worked on Windows, period. No Linux, no embedded systems, nothing. And second, DCOM was notoriously difficult to set up across firewalls. It was a massive security and networking headache. The very foundation of OPC Classic just wasn't built for the future of industry.
And that's where our story really begins, with a modern solution designed from the ground up to shatter those old limitations. So let's talk about OPC Ua, the universal machine language.
So, what is this thing exactly? OPC Ua stands for Open Platform Communications Unified Architecture. But what you really need to know is this. Think of it as a universal translator for machines. It's an open standard, which means no single company owns it, and it was designed from day one to be secure and to run on any platform. It's the common framework that lets totally different devices and software finally speak the same language.
And look, this isn't some niche tech cooked up by one company. OPC Ua is maintained by the OPC Foundation, a global nonprofit with over 800 members. And we're talking the heavy hitters. Siemens, Rockwell, SAP, Microsoft, Amazon, they're all in on this, working together to make the standard better. That kind of collaboration is why it's been so successful, and it tells you this technology is absolutely here to stay.
Okay, so we know what it is and who's behind it, but what actually makes it so powerful? What's its secret sauce? Let's break down OPC Ua's core superpowers.
First up, and this is a huge one, platform independence. This directly crushes OPC Classic's biggest weakness. OPC Ua just doesn't care if you're running Windows, Linux, or Mac OS. It can run on a tiny embedded chip inside a sensor, on a massive server in a data center, or on a cloud platform like AWS. That kind of flexibility is absolutely essential in modern industry. Next up, and in today's world, this is non-negotiable: security by design. See, connecting factory equipment to a network can be risky. OPC Ua was built with this in mind from day one. Security wasn't an afterthought, it was baked in from the very beginning. It uses industry-standard certificates, kind of like the little lock icon in your web browser, to make sure only authorized devices and people can connect. It encrypts all the data, it signs the messages so you know they haven't been messed with. It's the whole shebang. It's what gives companies the confidence to connect their most critical systems. And this might be the most important power of all: rich information models. See,
OPC Ua doesn't just send you raw data, like the number 25. That's just a number. It sends you information. It tells you that number is 25, the units are degrees Celsius, the timestamp was 2 seconds ago, and the data quality is good. This seems like a small detail, but it's a total game changer. It's the difference between seeing a number and understanding what it actually means. This context, this semantic data, is what lets you build truly smart applications.
So how does this all work in practice? Well, the basic setup is actually pretty straightforward. It's a classic client/server model. A client, say your factory's main control screen or an app in the cloud, requests some data. The server, which might be running right on a PLC or a sensor, gathers that data and sends it back securely. That's it. It's a simple, robust, and incredibly effective way to move information around.
Okay, so let's pull back from the technical details for a second. Why does all of this matter so much right now? Well, because it's literally the foundation for building the smart factory of the future.
This quote just nails it. Intelligent networking of factories requires a common language. This is exactly what OPC Ua delivers. You hear about Industry 4.0 and the industrial Internet of Things all the time, right? Well, all that cool futuristic stuff is built on intelligent networking. And you just can't have an intelligent network if everyone's speaking a different language. OPC Ua is that common language. It's the essential layer that makes it all possible.
So let's talk real-world impact. What can you actually do with this? You get machines talking directly to other machines, no middleman required. You finally bridge that age-old gap between the operational tech on the factory floor, the OT world, and the IT department's business systems, sending production data right into SAP. It's the engine that powers predictive maintenance, condition monitoring, and large-scale cloud analytics.
So think about where we started. A total mess, an industrial Tower of Babel where machines couldn't communicate. And now we have a secure, robust, and universal language that connects everything from the smallest sensor all the way to the largest cloud. So that leaves us with a really fascinating thought to end on. With a universal language for industry now firmly in place, what incredible new problem will we be able to solve next?